Hello, this is Charlene. We are here to work on part C of this projectile word problem. This is about John jumping off a cliff into the ocean. He's on vacation with friends, and his height as a function is modeled by h of t is equal to negative 16t squared plus 16t plus 480. Our question asks us, John hit the water after how many seconds? So again, it's always helpful to draw a picture and understand what this looks like visually. So John jumped off a cliff. This plus 480 actually means that he was up on this cliff way up here at 480 feet in the air. He jumps off the cliff, he jumps, and he goes boom, and he hits the ocean right there. And it wants to know, when did he hit the water? So, and it wants to know about the time. How many seconds is about the time? Typically, your time will always be on your x-axis. So that means that we need to figure out what that point in time is. Now, do you think it's going to take him hours to get to the ocean or minutes? Nope, it's just going to take him seconds. So we need to figure out how many seconds it takes him to hit the ocean. How many seconds? So we're going to figure out that point right there. So how do we find out points on the x-axis when it has to do with a parabola or a quadratic? Because that's exactly what this is. This h of t is equal to this. We know that when it says negative 16t squared, t squared is very informative to us, right? Okay, let me go ahead and get all that written out there. This part right here, the squared part, oops, I want a different color here, go back. Okay, so there we go. So that right there indicates that we are definitely talking about a quadratic. The power of 2. The highest power on our variable is a 2, an exponent of 2, and that means we are talking about a quadratic. Well, solutions to quadratics are things on the x-axis, so that is going to be one of our solutions. Now, technically, this parabola is going to come back down here and be somewhere in the negative time, but in real life, we would actually ignore that time because he actually starts up here on top of the cliff. But we want to find solutions to our quadratic. We're going to find solutions to this quadratic. How do we find solutions? We're going to factor it. Yeah, that's how we find solutions. Now, we can use the quadratic formula if you would like. That always works on quadratics, but we're going to go ahead and attempt to factor this one. So the first thing I want to consider is there a number that I can pull out or factor out of negative 16, 16, and 480? Well, let's check and see if 16 actually fits into the 480. Okay, so 480 divided by 16, and voila, it fits evenly. So that's what I'm going to do. I'm going to pull 16 out of everything. Well, because it's kind of inconvenient for me to have a negative in front, I'm actually going to pull a negative 16 out. And when I pull a negative 16 out, that means when I pull it out, that means to factor it out. I am left with negative 16 times what gives me negative 16t squared? Well, t squared is what's left. Negative 16 times what gives me positive 16t? Well, it's going to be a negative t. Okay, that's just a reminder there that when you pull a negative out, it's going to change these signs. All these signs are going to change when you pull a negative out. Okay, so let's go back to pulling the negative 16 out. So negative 16, when I pull a negative 16 out of the 480, that is going to be my 30. If you remember on the calculator, 480 divided by the 16 left me with 30. So there we go. Let me go ahead and get rid of all these green arrows because we don't need those. We want to have as much clear space and clarity here. Okay. So at that point, to find solutions, we actually do not need this part of the factorization. We only need to consider factoring this part. So t squared minus t minus 30 is a relatively simple quadratic to consider. We'll do the invisible 1 times the 30, so I'll consider factors of 30. That's supposed to be a 30, la la la. Okay, so let's do 30, factors of 30. Of course, we got 1 times 30, and we've got 3 times 10, and we've got 5 times 6, and we're trying to get this 1 here, that 1 here in the middle. So can I subtract 1 and 30 and get a 1? No. Can I subtract 3 and 10 or add them and get a 1? No. Can I add or subtract 5 and 6 and get a 1? Yes. So 5 and 6 is going to be my chosen factor pair, and that means that I am going to factor this in this manner. I'm going to put my t squared. What's the square root of the t squared? It is a t, so we're going to put a t right there, a t right there. Then I'm going to put my chosen factor pair, 5 and 6 in there, 5 and 6, and in order to get this -1, I'm going to have a -6 and a +5. Okay, so we need to understand and remember these are our factors of our original polynomial. So are the factors our solutions? No. The next thing we do is the zero product rule. Zero product rule says that we're going to say t plus 5 is equal to 0, plus 5 is equal to 0, and we're going to say t minus 6 is equal to 0, and then we're going to use order of operations to solve that. We would do minus 5 right there, plus 6 right there, and that means that t is going to be equal to -5 and t is going to be equal to a +6. So those are my two solutions, and what that means is that we have a -5 over here. If we were dealing with just numbers, -5 would be a solution. But in real life, there's no such thing as a -5 seconds. We do not go backwards in time in real life. So we would ignore that when we're going to reject that solution. But t equals 6, that's absolutely a good solution. So t seconds is when he is going to hit the ground again. That is the answer to our question because it is on the x-axis, it is a solution to our quadratic. So John hit the water after how many seconds? After 6 seconds. So hopefully that helps you think through the process, how to visualize it, and how to do the math of getting to your answer. So you just have a great day. Click on the like button, click on the subscribe button, and we'll see you later.